Okay, we are now going to continue our analysis of the files that need to be edited in order to configure the Coriolis application. We just discussed the cpp-defs file, and now we're going to discuss these additional two files that are actually Fortran source code, where we need to do some changes. The first file is models/mod_param.f, and this file is edited to define the number of grid points. So let's go one directory up. This is our source code directory. Then we go in the directory models and we vi mod param.f. When you open this file, you at the very beginning you start seeing a lot of comments, which commence here with this exclamation mark. And so this is a very long file, and you can read what all these parameters are. The ones that are interesting, the ones that you're interested in, are the ones that are relative to your Coriolis application. You can see that in this case you have a lot of if-def statements that characterize different types of application, like the Basin application, the 84 toy application, the Adriatic application, and so forth. So we want to look for the one that has the Coriolis configuration, which is down here. And so here you find a whole bunch of parameters. You find the LM parameter, which is the number of grid points in the x direction, the mm, which is the number of grid points in the y direction, n, which is the number of vertical layers. Then you have a parameter called NAT, which stands for number of active tracers, and in this case it's only one, because the only tracer in this example is the temperature, and so the density is only defined through temperature. And let me just say that when we talk about active tracers, we talk about tracers that have a feedback on the density and therefore on the momentum of the flow field. Ngrid stands for number of computational grids. For most applications this is equal to 1, because you're just doing one grid at a time. But if you were to have nested multiple grids, then this ngrids would be bigger than 1. Now these parameters are defined at the beginning of the file. So if we go up here and we search for NAT, you can find that here it tells you exactly what these are. Going back to the Coriolis, so this is the occurrence where the Coriolis block of definitions occur, and this is the only one in this file, and so we're really done with editing this file, and we can just close. Now let me just give you a little bit of hints here. So this is the directory structure here, and in general it may be useful sometimes to search the entire code for the occurrences of the Coriolis string, which characterize the options that are very peculiar just to the Coriolis application. And to do that, there's a nice Unix command that I wrote. It's called gggrep, and then you put the name of the string that you're searching for, in this case Coriolis, which is the definition for application. You press return, and this search automatically all the source code and the cpp-defs file. So you find that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 occurrences of this string, and these occurrences in fact happen to the files that we need to edit. The first one is mod param, and there's only one occurrence, which is what we just did. Then there's this other file here that's analytical.f, which is going to be the object of the next demo. And then we have applications cpp-defs, applications Coriolis and dev, which cpp-defs, which is the file that we added in the previous demo, which has all the definitions. And here in fact you see that there is the place where you define Coriolis, and then the block if defined Coriolis is the beginning of the block where you have all the various additional options that characterize the physics that you're using, for example solve 3D and so forth. So for example, if you're interested now in understanding where in the model the physics corresponding to the east-west periodic boundary conditions are occurring, then all we need to do is we go here and we do gggrep, then we type east-west periodic, and you find all the places where there's blocks of codes that are relative to the east periodic thing. So then you can just go here, for example, open one routine. This is just an example, of course, and then search for the string east-west periodic. There it is, east-west underscore periodic, and you can search here and you'll find all the places where there's blocks of codes that are peculiar to this option. So this is it for the file. Let's go back into applications here. So Let's do more of coriolis readme. Okay, so now we've done again, we've looked at this file, and in the next demo we're going to look at the analytical.f.